And now let's talk about that third part. We've discussed fiber, we've discussed matrix systems, and I brought some samples of core material to show you here. These are two common cores used in composite construction. By adding a core between the face plies or the fibers, we can add thickness, and that core adds rigidity. Now this core material here is commonly used in composites. This is referred to as honeycomb material, probably because it looks like, well, honeycomb. The bees had figured it out. This is a very desirable design to make this structure out of, and this honeycomb material is lightweight, so there's very little weight penalty to pay, but we can get a lot of rigidity out of this material by adding some thickness to the part. As a matter of fact, in many cases, by adding a core material, we can make a part up to 37 times stiffer without much of a weight penalty. That's a pretty awesome gain. Honeycomb material can be made in different thicknesses. It can be bought in different sizes, up to sheet sizes like plywood, and it can be made out of many, many different materials. Each honeycomb material is good for specific purposes, so we would always match our core materials, just like our fibers and our resins, by looking at our repair manuals or going to the manufacturer's manual and making the right selection. Another common core material that can be added to composites is foam. Now this is not the standard foam you would see all over the place. This is not cooler foam. This is a specific urethane foam that meets the requirements to be aircraft grade. Now there's a few different chemical compositions that are used to make this foam. This is a urethane foam, which is a common foam. It's a little denser and a little harder than a lot of the softer foams like styrofoam. Plus it works well with the chemical systems, so it doesn't attack and harm this foam. Now foam can also be bought in different sheet sizes, different thicknesses, and in some cases different chemical compositions. We won't go too far down that trail today, but just understand that this is an awesome core material. Once again, we get a lot of rigidity with a very low weight penalty. So adding core material can help create a stiffer and stronger part. All we have to do is know how to combine these things together in the right order, create the right pressure, right temperatures, and we can make an awesome part. That covers our three major components of composites, and let's take a look at all three of these parts combined. This part here includes the fibers, it includes core material, and of course the resins that were used is the matrix system to bond this part together. Now this particular part happens to be a piece that was cut out of a Black Hawk helicopter rotor blade. And if you think about what we've discussed thus far, we've got fibers, and in this case carbon fiber. We have core materials, honeycomb and foam, and then of course the resins or matrix system necessarily to bond all this together to make a part. In this case, with this rotor blade, this part is extremely strong, very lightweight for the strength, yet it flexes enough, because rotor blades flex a lot on helicopters, it's flexible enough it won't crack, causing a serious issue. So if we combine these materials in the right way, we can create a very advanced part that would be very difficult to make any other way. I hope you've gained something from this second segment, and I look forward to seeing you again.